Today we will be solving a 3-digit by 3-digit addition equation. We will be adding 452 and 389 together to find the sum. We will begin by estimating the sum. To do this, we will use the estimation strategy of rounding. When rounding, we need to round to the nearest place value. For 452, I would ask students whether it is closer to 450 or 500. We would round to 450 because 452 is closer to 450 than it is to 500. For 389, we would round to 400, the nearest 100, because it is closer to 400. 450 added together with 400 is 850, so that means that our equation is about 850. Using estimation makes problems like this easier to add. We will now solve this problem using movable base 10 blocks. We know that 452 needs 4 flats of 100 tiles to make 400 in the hundreds place value. We need 5 rods of 10 to make 50 in the tens place value, and we need 2 individual 1 tiles for the ones place value. These together represent 452. For 389, we need 3 flats of 100 tiles to make 300 in the hundreds place value. We need 8 rods of 10 to make 80 in the tens place value, and we need 9 individual 1 tiles for the ones place value. This together represents 389. We will now slide both of these together in order to add them. Now that both sets are together, we can see that there are 11 individual 1 tiles, 13 rods of 10, and 7 flats of 100. Do you see the problem? We know that 10 individual tiles is the same as 1 rod of 10. Therefore, we will take 10 of the individual tiles away and replace with 1 rod of 10. We know that 10 rods of 10 is the same as 1 flat of 100. We can take 10 of these rods away and replace it with 1 flat of 100. Now we have 8 100 flats, 4 rods of 10, and 1 individual tile. Therefore, our sum is 841. We will now model this in a similar way as last time, but this time we will draw the blocks. As you can see, I followed the same procedure as with the movable yellow base 10 blocks, but this time I drew an arrow to show that 10 individual red tiles moved over to become 1 rod of 10. I circled 10 green rods of 10 together and used an arrow to show that it became 1 flat of 100. We now have 8 flat 100 tiles, 4 rods of 10, and 1 individual tile to represent the sum of 841. We will now use partitioning. When partitioning, we split the numbers into hundreds, tens, and ones. Keep in mind place value. How many hundreds do we have? So we have 400 and 300, which has a sum of 700. How many tens do we have? We have 50 and 80, which has a sum of 130. If students are not comfortable with adding 50 and 80 together, they can partition the numbers even further as shown and add the smaller numbers together. How many ones do we have? We have 2 and 9, which has a sum of 11. Students can now add 700, 130, and 11 together, but if they are not comfortable adding all 3 numbers together at once, they can add 700 and 130 together first to reach 830, and then they can add 11 onto that to reach the sum of 841. For our final strategy, we will use something called an open number line. For this strategy, we always begin on the left side, so 452 would go right here. Using what we know about partitioning, we can partition 300 into 3 jumps of 100 each. For each jump, students would add 100 to the number they have. So 452 plus 100 has the sum of 552, and 552 plus 100 has a sum of 652, and so on. Students can partition 80 into 8 jumps of 10 each. And 9 can be partitioned into 1 jump of 6 and 1 jump of 3. Adding all these numbers together would reach the sum of 841. If students feel more confident, they do not have to partition the larger numbers into smaller numbers. They can choose to add 300 as one jump, 80 as another jump, and 9 as the third jump. Looking back at our original estimate, we were quite close to our final sum of 841. Our estimate was just slightly higher than our sum.